Hi everybody, welcome back. So we have another MATLAB assignment. Woo, MATLAB! If you don't like MATLAB, oh, MATLAB. But do what you feel like. Do what you feel like. It's okay. So let's go through some stuff. So first off, we had our continuity equation. We've had it for a little while now. And we know that we can simplify this because if we have a steady flow where all of our derivatives with respect to time are zero, and an incompressible flow where density is constant, then it turns into this, which is simply saying the divergence of our velocity field is zero. The gradient dot with the a vector field is the divergence. And so if this is equal to zero, that means we have a steady incompressible flow. Nice, that works. At the very least, we have an incompressible flow. Nice. Okay. So let's keep on going here. So if I go down here, I've got a little code. And so for each of these things, I would suggest you click on run section, not run. You can click either one. Sometimes you have to do run. I'll go ahead and click run. That'll run everything from beginning to end. But you'll end up having to do some things again. It'll be fine. Okay, now when I did that, this guy popped up. I'm going to bring him over here so it's a little bit bigger. Now what is this? Well, this is a vector field. It's a vector field. And you see, okay, I got little white vectors. And this is actually a vector field of velocity. See, MATLAB has a bunch of built-in data sets like you see right here. And so I loaded in a wind data set. Hey, this is wind data. Nice. And then I used some special matrix commands to take out a particular two-dimensional slice of this. And MATLAB has a built-in function to calculate divergence, so I did it. So, got divergence right here calculated. I got everything else calculated. Nice. Looks good. Okay. Now, one thing I'll notice, though, is I calculate divergence, and that's actually the color scale over here. And if it was zero everywhere, it would be the same color right here. I think actually would have got an error message because it wouldn't let me do this kind of plot if it was all the same value. But it's not the same value. You can see it goes up to about negative, or up to +5 and down to -5. So there's variations here. Now, a question we might have is, well, why is it not zero? That could mean that 1, the flow is not incompressible. 2, maybe the flow is not steady. Could be. Honestly, my personal opinion, I've checked this actually. A good example, a good answer would be simply that this is a two-dimensional divergence of a three-dimensional field. The 2D divergence doesn't have to be zero. The three-dimensional divergence does. So if it was truly incompressible, the three-dimensional divergence would be zero. Is it? No, it's not. But honestly, this is probably because MATLAB is making this data. It's probably not real data. And if it is, maybe it's just because we have such a big grid that it didn't come out to be zero. Okay, now let's figure out how we can work with data like this. Because I took all these little things right here, matrices, and I used them to make this. So if you know how to make matrices, you have easier time of it. Warning, graphics timeout occurred. Oh, well, there it is. Why were you in trouble then, dude? I don't know. Okay. Either way, so if I know how to work with matrices, I can do all kinds of pretty stuff because MATLAB has a bunch of built-in functions. Like, for example, a streamline function. What's a streamline? Well, you'll find out, or maybe you already know. Either way, it's a very helpful function. And it puts these little pretty lines on there. I like it. And what are they for? Find out. Okay, so let's get back to matrices. So what are matrices? Well, they're kind of like a vector. A vector is just a series of numbers that tells me how far I'm going in the X, Y, and Z direction, or how to point a particular arrow and how long it should be. A matrix is very similar, but instead of being one-dimensional, so just a row of numbers, it is multiple rows of numbers. Now, if you look at these two things, one gave me a vector, which is just a row of numbers. That one gave me multiple rows of numbers. And the reason for that is because I put a semicolon here. Semicolon tells me I have a matrix. Okay, so let's try out this first example, and then we'll pause here, and I'll have another video for the next few examples. Don't want to make this too long. So, make my day. Okay, for this example, create a matrix called my matrix, which has 2 rows. The first row should contain the numbers 1 through 4, counting by 1. The second should have the numbers 2 through 8, counting by 2. So, okay, we can do that. It's not too bad. So I'm going to make my matrix. So my matrix, okay, is equal to square brackets. That makes it a vector or a matrix. And then it's going to be 1 through 4. So 1 space 2 space 3 space 4. You'll notice there's no commas there. Don't have to have them. Spaces work just as well to separate one column from the next. That semicolon says I'm now on the second row. 2, 4, 6, 8. I'm done. Cool. If I run this section, which I'm going to, there it is, my matrix. If I go over right here to my workspace, I can actually double click on my matrix and open it up in the variable editor. And if I want to, I could even change these numbers. I can add to it. I can do all kinds of things in the variable editor. So it can be very, very helpful. But I don't need this anymore, so I'm going to close this, jump back here. Okay, with that, we're done for this. I wanted to show you that MATLAB has some amazing built-in functions that you can use those built-in functions to do things much, much easier than you would do it by hand. And finally, that if you're going to be able to use those functions and use them effectively on real data sets, you're going to have to learn how to deal with matrices. So, thanks for paying attention. I'll see you all later. Bye-bye.